So we have quickly sort of, set up this variables. Now setting up an account. Okay. So we need to set up an account with our CLI like this. So I'm going to call this account. Okay. So, oh, my screen sharing is paused. Let me stop sharing and share everything. Okay. So now what we are going to do is we are going to create a new account, right? So we are going to use Starknet new underscore account hyphen account and then name of the account. So I'm going to say this account, I'm going to call it Starknet BLR. Okay. So this will give me a public key, an account address and a public key. Okay. This will be stored in your system as well as a JSON file. So you don't have to worry about saving this right now. But if you want to, you can also save it. So here, this is the thing that is important for me. That is the account address. I'm going to copy this and then I'm going to use the faucet. So I've opened the faucet. So faucet is the one from where you can get test funds, right? So I'm going to copy my account address here. I've just passed this check and I say send request. Okay, sending testnet ETH to your account. Please wait a moment. So how can you see this transaction? You can click on this transaction and it will open in an explorer called Starkscan, right? So Starkscan is the explorer that we'll be using. Starkscan, you can see that there are 5 stages for a particular transaction to actually get confirmed. So first is not received, but it has received the transaction. Next will be pending. That means it's still processing it. Once it reaches accepted on L2, that means we can continue. The last stage is accepted on L1. What this means is once it is accepted on L2, there is an element on Starknet which called the sequencer, which creates blocks on L2. But the final thing is the proof has to be verified on L1, right? So that is the last stage. That is the proof has been verified on L1. So right now we don't have to worry about it. Once it is accepted on L2, it's as good as it being accepted. So we'll just go with that for now. So once it reaches accepted on L2, that means this account will be funded, right? So why do we need to fund this account before deploying this account? Because this is a smart contract account. So to deploy this smart contract, you need funds, right? So that's why we are funding this account and then we will deploy this. So this is like a self-deployment strategy. So basically something like a factory contract, which will create an account for you. It will give you the account address. You will fund that account address. Then you can use those funds to deploy the smart contract. So it's still pending. Once it goes to accepted on L2, then we can deploy the contract. This is the account contract. And this is the name of the account, Starknet BLR. So you just need to remember the name of the account. Wherever you're going to use this account, you can use this reference. Okay. So this will take a while, maybe another 1 or 2 minutes. So meanwhile, let's start with the coding part of it. Okay. So whatever just file I have shared with you, this is an incomplete contract. We are going to at least bare minimum, let's try to deploy this contract, compile bare minimum. Let's try to compile this contract and then we'll try to deploy, interact with it based on how much time we have. Okay. So let this transaction keep going. It will take a few seconds more, another minute or so. Once it is accepted on L2, you can write the next command, which is deploy, right? Deploying this account. So like this, Starknet deploy account, hyphen account, then name of the account, Starknet BLR. I will deploy that. Once it is deployed, again, it will take a while. And okay. So let's start. So I have copied this contract. I'm going to move this. Yeah. Okay. So I have this contract called voting.cairo. This is a simple contract where we are going to have few functions. Let me just explain the overview of this. And how I would like to go about this is everything that is TBD. I'm going to write one of the TBDs and I'm going to ask you if you can. So maybe I will write the first function and I will tell you that for the next one, this is similar to that. And if you can write the answer in chat, that would be great. So I will know that you also know how to write a contract. Okay. So let's get started. So this is a simple contract. So you can see that every time you're writing a Cairo contract, you have to start with a macro contract. You have to tell this you have to tell the compiler that this particular module is a Starknet contract. Why do we have to do this? Because Cairo is a programming language, right? So you can use it for not just writing contracts, but perhaps whenever there are lots of other different use cases that are being explored, right? So you can use Cairo for different purposes. Here we are using Cairo for writing a smart contract. For example, think of Rust. Rust is a general purpose programming language, but different other blockchains also use Rust for writing smart contracts. But they specify certain attribute for that Rust code, telling the blockchain that this is a smart contract. So that is what we are doing here. That Cairo in itself is actually a programming language. But here we are using Cairo to write a Starknet smart contract. So we have to provide this macro called contract. And then as we saw that all the code will be encompassed within a module, we are going to say module and the name of the module is vote. And within this entire curly braces, we will write all of our code, right? So first we are doing some core library imports. We want to use the contract address, which is a variable, which is a data type, as we saw, for storing addresses of the voters, right? So we have some mappings, whether this particular voter voted or not, whether this particular voter is eligible to vote or not. All of these checks we can perform with the help of the address of the voter. And then we are importing another functionality from Starknet, which is called get caller address. So if you're familiar with message.sender, this is something similar to that, where you can get the address of the account that called this function. So that is get caller address. Then we want to have arrays. So we are going to import arrays from this trait called array trait. I don't think we are using arrays in this from what I remember. But if you want to use arrays, then this is how you can take this. Okay. Now, storage. What are the different types of storage variables do we need? So we have a structure called storage, and we are going to have, so in this particular voting contract, think of this voting contract as just one proposal. Okay. There is a particular proposal that's for which this voting contract has been deployed. Certain number of voters, there'll be 3 voters that are going to be registered, fixed number of voters in this contract to make it simple. And each of these voters can either vote yes or no. So we will count the number of votes and we will also count the percentage of votes for this particular proposal for which this contract has been deployed. So now we have a struct called storage. Within this struct, we are going to have number of yes votes. So this is of type U8. And then we have number of no votes, which is again of type U8. We have a mapping called can vote, right? Maybe we want to check whether this particular voter can vote or not. Maybe they have already voted, so we don't want them to vote again. So the data type to create mapping is called legacy map. The syntax is legacy map followed by 2 colons. And the mapping is between the contract address and Boolean. Then we have a registered voter. We are going to check whether this particular voter is registered or not, because we are registering a fixed number of voters, right? So anybody should not be just able to come and vote. So for that, we are creating a mapping called registered voter, which is again between contract address and Boolean, whether this particular contract address is a registered voter or not. So these are the variables that we are going data structure, data types, variables that we are going to use throughout our program, right? So because these are in general storage. Now, if we want to create variables within our function, we can use the keyword let, L-E-T, let. We'll see that now. Okay. Then now let's start the logic. Is the objective of the contract clear to everyone? We will register 3 voters. Each of these voters can vote yes or no. Finally, we will calculate how many people have voted yes, how many people have voted no. Very simple logic. Is this clear? Is the logic clear, or are there any questions? Can people vote yes or no? Sorry, is there a question?
Yes, but what does the second mapping do? The registered voter.
This checks whether a particular address is registered or not. See, because we have only fixed number of registered voters, that is 3 voters, and we are going to manually register them in the constructor. So no one else should be able to come and vote.
Okay.
And can vote is for whether you have already voted or not. If you have already voted, you can't vote again. So when you're trying to vote, it will check whether you can vote or not. Is that clear? Okay. Okay. So let's continue. So what are we doing in the constructor? We are going to register 3 voters. So we are going to register a voter 1 of type contract address, a voter 2 of type contract address, a voter 3 of type contract address. It says register all the voters by calling the register voters function. So there is a function called register voters. Let's find this function and see what this function is doing. This function is an internal function. You see that there is no macro here. There is no view macro. There is no external macro or anything, right? By default, all the functions are internal. That means you can call them only internally. So this is an internal function to prepare the list of voters. Index can be the length of the array. So we don't have arrays. I think initially the idea was to have arrays, but it would have become too complicated. So we just decided to go without the arrays. So here we are going to register all of the voters. Is it important? Can vote before? Yeah, yeah, correct. It should not matter. You're right. So cost of answer that struct is just a composite data structure. So it should not matter whether you have can vote above or below. Okay, so I'm going to register the first voter. So I have 3 voter addresses, voter 1, voter 2, and voter 3. I'm going to fill up all the 3 mappings. Okay. So I'm going to say can vote, right. And I'm going to say voter 1, sorry, underscore 1, false. Oh, sorry. True, they can vote. Then I'm going to say registered voter, right. So I'm writing to this mapping. So first is the key, that is the voter address. True. Okay. So I'm going to write each of the voters. I'm going to fill both of the mappings. That voter 1 can vote, yes, and they are a registered voter. Can you both quickly, can everyone just quickly also register the second and the third voter? Did you understand what we are doing? And did you understand the syntax as well? We are taking in 3 parameters, voter 1, voter 2, voter 3. Can vote and registered voter are 2 mappings between contract address and bool. So we are filling up the contract address and bool. Is that clear? Once you have filled this up, can you write ready? So we can go to the next step. Once you have filled both the second voter and the third voter TBDs. Done. Okay. Ram Kumar is done. What about Hanner, Kaustav? What about others? Saurabh, Ananya. Wait, let me see what the other people I'm called. Naresh, Ashna, and Ananya. Can you also just code? It's fine if you're not able to compile. That's okay. Don't worry about it. You can just code with me right now. Okay. So done. Okay, great. So I have at least 4 done. So I'm moving forward. I need to fill mine as well. I'm going to quickly just do voter 2. Voter 3. Okay, perfect. Can someone paste the contract here? Kaustav, I will give you the gist link of the contract that I gave everyone. There you go. Okay. All right. Let's go. Let's go. Okay. So this is the first thing. So now we have done this according to the according to this instruction over here. It says register all the voters by calling this. So we need to call the function that we just filled up. So we are going to call it. And what are the parameters that it takes? It takes voter 1, voter 2, and voter 3. Okay, simple. Okay. It does not return anything, so we don't have to store anything. Now it says initialize the vote count to 0. What does that mean? That right now, both of the yes votes and the no votes should be initialized to 0. This is also again very simple. We will take yes votes and then we will write the value of that to be 0. Okay. Can you also similarly please do the no votes? Write 0 to no votes and let me know once you're done. So in the constructor, we are registering 3 voters. We will be sending the address of these 3 voters and then we will be registering them. Can you please write on the chat once you're done? You need to fill up this thing called no votes. Come on, it's just one line. Okay. Okay, done. But is it like default equal to 0? Yes, that's what it is. It is like, it is similar to default is equal to 0, but just for safety, we will have to, we are going to write the value. I don't think in Cairo it takes default values, but I can double check that. That's why I have seen everywhere that we write the values explicitly in the constructor. Let's see. Check the Cairo. This is fine. By using these integers. Oh, no. I think for contract type safety, it's probably better to initialize. Yeah, only for the tuple, I can find that it is represented, tuple size is always 0. Makes sense. Okay, I will check and come back. Yeah, write method will override the default value. That is correct. But I don't exactly know that even default uh, value will be 0. That is something actually we can actually check without even writing. Why not? So I am not, let's just check this in this contract. By default, it takes 0 value. Okay, great. Thanks, Ram. So then for no votes, I'm not writing anything, assuming that by default it takes 0 value. Okay. Now the next thing that we are going to do is we are going to see some of the getter functions. That is, okay, before that, let's go to the main function, which is the voting function, right? Oh, I think voting function needs the above function. So we need to fill this up. Sorry, my bad. So we are going to work on the get functions, wherein these are only going to be view functions. Let's see what the first function says. Return the number of yes and no votes. So this is very simple. It will return, we need to return 2 U8s, right? So how will we return? First, we will read the number of yes votes and no votes from storage. Can anyone tell me how we can do this? How will we read the number of yes and no votes? Do you remember that for writing we used write? So what do you think we'll use for read? With view? No. So view will be the macro that is used for read-only functions. So the macros we have to specify above the function. Okay, Kaustav says we can use read. That's right. Can you tell me, Kaustav, can you also write like what will be the syntax over here? How will I read the number of yes votes? See, we know the variable that we need to read. That is yes underscore votes, right? What will be the syntax here? Yes. So we are going to say, we are going to have, say, let's say something like this. Let yes equal to yes underscore votes colon colon. Okay. And then we say let no is equal to no votes colon colon read. And we have to return both of them, right? So we are going to say yes, comma, no. Okay, we have to return 2 values. So I'm returning both yes and no. Is this clear? Shall we go to the next one? You can also write it like this. Or like this. So both of these work. So this concept of return again is similar to Rust. The last statement, whatever is the last statement in your function, becomes the return value automatically. And you don't actually have to write return. But if you want to have like safety and you want to make sure that, you know, that statement is not an expression or something like that, then you can add a return and a semicolon. Like, okay, just in the interest of time, I'm moving on to the next one. What is this function doing? Returns if a voter can vote or not, right? So what is the function for that? We have a mapping called can vote. So for a particular voter address, can that voter vote or not, right? So we can return very simple. We just need to read this particular mapping with the address of the user that has been sent. So we can just do this. That's it. We don't have to add the return statement because this is a single statement. So this particular statement, the result of this will be a Boolean, right? Because we know that for this particular mapping, if we send the key value, we will get the value, key value pair, right? So can this user, can this address vote or not? So actually it will be, if you want to see this in more complex stuff, you can have something like this. So like this, and then you can also return like this, right? So can vote status, the status of this particular user address, can they vote or not? We can get in this variable and then we can return. But this is a lot of lines, we don't need it. We can just have in one single line. Okay. So this function is voter registered. This is also similar from voter registered mapping. We need to get this particular address and we need to return. So this will be the exact same function as this. So if you can fill up this function, that would be good. I'm not going to do this. I'll let you fill this up. Please fill up this TBD. And once you've filled this up, post your answer in the chat, what you have filled up over here, and whichever is the correct one, I'm just going to copy paste. Okay. Once you fill this up, please post your answer on the chat. The next function that we are checking is this particular voter registered? So it's going to be the exact same thing. We just need to read a mapping from this particular address. The value of this key. If you have completed, please post your answer in the chat. Okay, I see 1, 2. Yes, okay. Ram Kumar has shared. So, Ram Kumar, you have shared one answer. Part of your answer is correct. But others who are looking at that, there is a small mistake in that. Can you tell me what is the mistake? We don't need the semicolon. Exactly. So, let's put it over here. We remove the semicolon. Why? Because once we add the semicolon, it becomes an expression. Oh, sorry, becomes a statement. Statement or expression. Let me quickly verify that from Rust. So, okay, expressions return a value. Yeah, so once we put a semicolon, it becomes a statement. However, expressions can only return a value, not statements. So this is a concept taken from Rust. Gotcha. Okay. All right. So we are almost now done. We are coming to the main function, which is the vote function. What can a user do with this vote function? They can submit a vote, 0 for no and 1 for yes. Okay. So if they submit 0, that's a no vote. If they submit 1, that's a yes vote. And then we are taking a param called vote, which will be their vote, 0 or 1. And then we will return, which is we are not returning anything, but we are going to update all the storage with the vote count and mark the voter as not allowed to vote anymore, right? So first thing, we have to check whether the vote is valid or not. This is where we will use something called as assert statement. Okay. So we are going to check assert if the vote is equal to, can I say 0 over here? Can I write like this? Will this be correct? Can someone tell me if this comparison will be correct or no? And okay, I will tell you, this comparison is wrong. And to correct these, you need to think about what are the default data types in Cairo. What is a default data type in Cairo? And if you got the answer, then can you tell me how I should write this statement? Boolean, no. What is this? What is the data type of this? This is U8, right? So you can compare this with only U8, right? So how will I write 0 as U8? Yes, perfect. So 0 underscore U8. and 1 as well, because the default data type in Cairo is felt 252, because it is a language that depends on field elements, right? So default data type is felt 252. So 0 by default is felt 252. So you have to convert it to U8 in order to compare it with both. So, and here we can write an assert statement that vote should be 0 or 1 only, right? So there is a character limit on this as well. It is very small. I think it is 2 bits or something like that. So I don't know the exact value. But if we write a longer one, compiler will throw an error. We can see from there what is the character limit. So the character limit is very small. So we have to write a very small and concise error message. So what we are doing here is we are checking if the vote value is 0 or 1. If it is not 0 or 1, we will give this error message, which will tell the user that you can vote either 0 or 1. Okay, this is the first assert. Now, what are we doing next? We are checking if a voter has already voted and continue if they have not voted. So we have to get the caller address. That means who is trying to vote, right? Is it voter 1? Is it voter 2, voter 3, or any other address, right? So we are going to get the address of the contract or address of the account that is trying to call this function. Somebody is trying to vote, right? One account is trying to call this function. So which is that account? We are trying to get the address of that, like message.sender in Solidity. Because we have only 3 voters are registered, only they can vote. People randomly can't vote. So there is another function called assert allowed, where we are passing the address of this caller and we will check if this caller can vote or not. So we have to assert both of these above variables. That is this voter a registered voter and can this voter vote? So how will we assert? So we will assert if is voter, it is a Boolean, right? So it has to be what? Can someone tell me? What will be the Boolean value? How will we assert over here? What should this assert be? We are asserting a Boolean value. So with what value should we compare? Okay. True? Yeah, correct. True, false. So right now this should be true. Otherwise, we have to throw an error message saying not voter. Or we can say, okay, not registered. Okay. So is this person a voter? Is this person a registered voter? We are going to assert that. And we are also going to assert if they can vote, right? So can vote, true. If they are not, then we say already voted. Okay. So we are going to assert this, and this is called assert allowed, where we are checking both the asserts for this particular user address. And if both of these asserts come out to be true, then we will now we will count the voters count, and we will mark that this voter has already voted and update in the storage. So which variable do we need to mark to update this voters ability to vote? Can you tell me which variable will that be? Which variable should we mark to say that this particular voter has already voted? Okay, think about it. Here we are checking 2 things, right? So what should we mark over here? Can underscore vote. Yes. So we are going to use can underscore vote. We are going to write that now this particular caller cannot vote anymore because they have already voted. Okay. Now we are going to update the storage. So what and all what are the possible votes that this voter could have sent? They could have either voted 1 or they could have voted 0, right? So let's check for those conditions and say if vote equal to 0, then we will say yes. Oh, sorry. No underscore votes, right? Okay. So now we have to read the existing value of the no votes and increment it by number 1. So we will say no underscore votes read plus 1 underscore U8. Remember, because the type of vote is number of votes, the type, no votes, the type is U8. So you'll have to typecast. So we have done with this. Similarly, you can do for else. Oh no, let's just do else because we don't need to do the comparison. So is this clear? We are taking the no votes, we are reading them, the existing number, we are incrementing by 1. Yes votes, we are reading them, and then we are incrementing by number 1, and then we are writing it to the updated variable. Are we returning anything here? No. So we are good. That's it. It's very simple, right? This person sent a vote. We check whether the vote is 0 or 1. If not, we raise an alert. And then we get the address from which this function was called. We make sure that all the asserts are completed. We update their ability to vote. And then we update the no or the yes votes. So this is a simple write function. Now, let's see if we left anything. No. Perfect. So this program is completed now. The next step is to be able to compile this program, right? Okay, so I need to deploy this account. So let me do that very quickly. I'm going to say deploy account and then name of the account. Okay, so I'm sure your contract also, would have been, funds would have been added successfully. So you can run this deploy and leave it, right? It will take some time for this transaction to go through. Let's focus back on our contract now. Okay, so I have this contract called voting.cairo. Let's see if it compiles. So we need to use Starknet compile. And then we will compile it to a JSON. Okay. Okay. So lot of errors. Let's see. Okay, sorry. So I made this mistake last time too. This is not double, single. Okay. Anywhere else? Do we have any asserts? So the error message of the assert should be in single quotes, not in double. I made the same mistake last time. Interesting. Okay, let's see. Expected argument. Oh, okay, I'm gonna fix this. Let's see this program. What? Okay. So or is this what I missed? And single quotes. Okay. I'm going to quickly fix that. There's only one for or. Save that. And then, okay, somewhere I have missed semicolon 38. Okay, here. Okay, anywhere else? 72, 72, same thing. Okay, okay. Expected. Okay, perfect. So here it threw me an error that it expected U8, but I actually wrote fell 252. So I did not typecast this. So that was wrong. Okay. Okay. So now it has compiled, and you can see that there is a new file called voting.json that has been created, right? So are you able to compile? Are most of you able to compile? It's basically the same contract that is here that we wrote. So if you want for reference, you can check this out. Are most of you able to compile? So this is where you can see how you can compile, how you can deploy and stuff like that. Okay. Yes. Okay. Ramkumar, you were able to compile. What about Kaustav, Hanner? Token has not been transferred yet. Oh, no problem, Kaustav. You can compile. Your compilation is irrespective of that. So we will need the account to be activated before deployment. You, Hannah, you are not able to deploy your account. Why? What is the issue that you're facing? Client connector certificate error. Oh, that seems weird. Uh, can you share your screen? So I'm going to check as well if my account is deployed. I should have taken deploy account. Let's check the transaction has. So I'm also checking for my account if it has, see this one, previous one, when I created the faucet funds. Okay, this is also accepted in L2. So my account has been deployed now. So my account is created. Uh, okay, I'm going to quickly show you how to declare the contract, and then we will debug why you're not able to. This one. Okay, so here deploying account contract, this is your account contract and stuff. So first, what we are going to do is we are going to declare the contract. So to deploy the contract, there are two steps. The first step is called declaring the contract. So if you come to this chapter 1.4, you can see that once you have compiled your contract, you will need to declare your contract. So we have compiled our contract like this, compile hello to JSON. And then we will declare a contract class. So we use Starknet declare. So let me show you that very quickly. And then hyphen contract, the JSON that we compiled. So voting.json. Okay. And then we are going to use the account that we created newly. Okay. So I'm going to use hyphen account. My account was called Starknet DLR. Capitalize. Oh, was it smallish? Let's see what was the name of my account. Smallest. Okay, I'm just gonna copy this so I know that. Okay, smallest. So Starknet BLR with B capital. Okay. Okay, so it's trying to declare. Okay. My compiler is an old version, so it is not allowing, but okay, never mind. So I hope that you should be able to. All of you all have the new compiler version. So only compiled version 1.0. I got an old version. My compiler is old, so it is not. Okay. So never mind. If you all have since you all have 0.11.1, you should be able to declare your contract like this using the account that you have that you created. Once you have declared your account, then you can deploy your account as well, like this. Starknet deploy with the class hash that was generated in this declared step, you will get a class hash, right? And like this. So once you've got a class hash after declaring, you have to use that class hash to deploy this particular contract using the account that you have created. Okay. Once you have deployed, then you can interact with the contract. You can check the steps over here, right? In the chapter 2, you will see there is a section called deploying, calling, and invoking contracts. So how do you deploy? How do you, all of these steps are there for this particular voting contract, right? What functions you can invoke, what should be the inputs that you should send, and all of that. Now let's try to debug what are the issues that you're facing. Can you repeat just once how to deploy once code is ready? Okay, sure. Once the code is ready, once you have compiled, right? First thing you have to do is compile. So if you have successfully compiled the contract, right? Here there is nothing called compilation, but we did before all of this started breaking, we did this. Starknet compile voting.cairo to JSON. Once we have compiled the contract, we have to next go to this thing called declare contract. Okay. So let me go here, 1.4. In chapter 1.4, you can search for declare. So what does this mean? Declare means that you're telling basically the testnet that, hey, this is the JSON that I'm going to deploy, right? So you can also deploy anyone else's declared contracts, right? Because you are just saying that you're going to use that structure and you're going to deploy the contract. So you're declaring this particular JSON using the account that you have created. Once you have deployed your account successfully, your account would have been created, and then you can declare the contract using this particular account. Once you have declared it, you will get an output like this, sending the transaction with max fee, and then declare transaction was sent. You will get something called contract class hash. You have to take this contract class hash, and then you have to use the deploy command. Starknet deploy -- class hash, and then the address of the class hash using the account that you have created. So you have to declare first, then you have to deploy. Okay, compilation is done. Kaustav, can you try to declare and deploy? I have an older version of the compiler, so unfortunately not happening on mine. I will quickly update it in a bit. I'm going to stop recording.